Welcome everybody that's joining. I see a few people. I have a window here where I can see folks. Helena, Sarah, Sahar. Feel free to introduce yourself in the chat window. There's a chat window there. I'm hoping for people to ask questions throughout the talk, as I'll repeat a couple times, but once I get started. But feel free to introduce yourself, where you're from, if there's a particular use case that you're interested in.
While we have time, I'll enter a use case.
Hey, Helena. Based in Toronto, originally from Vancouver. Beautiful. Yeah, that's what we all hope. Write our reports and essays. So I'll see if I can show you an example of that. And you can judge for yourself whether it's ready to do it. Yeah, how to use generative AI. Bintu's asking how to use generative AI to use for clothing and 3D printing. If I have time at the end, I'll do a little bit on generative AI for the visual domain. Most of what I'm going to be talking about today is more for the text domain, just because we had so much to talk about. But actually, one of the most exciting things that's on the horizon is images, visual content, and even 3D content. Clinton says he's from Toronto, so some local folks in Toronto looking at generative data for testing models in sandbox environments. So I assume, Clinton, is that synthetic data that you're looking for? Very cool. Yeah, that's an example of another example that a lot of people are seeing. It helps preserve privacy, generate synthetic data from privacy to preserve privacy in many cases. Did I have to do anything there, Bintu? It said enter segment. Did I have to do anything or no? I'm good to go.
I think we're good.
Okay. So if you're joining, everybody, feel as I'll say in a second, please introduce yourself in the chat and put a use case that you might be interested in. It's super helpful. I'm still looking at chat to be able to see who's here and what you're thinking about. So we already have a few good ones.
All right. Looks like we're ready to kick it off. All right, so I have Tristan, Zajonc, CEO and co-founder of Continual AI, and he'll be discussing automating knowledge and working with generative AI. Enjoy.
Thank you, Bintu. So, hey, thanks everybody. Welcome. I hope you have a fun. I'm not sure if this is going to be 30 minutes, if it's going to be 45 minutes, or it's going to be an hour. I've got a lot of interactive demos, allowing you to sort of get myself to sort of show you generative AI in action. And so we'll see. I'll switch back into the chat from now and then, and if people have questions, we can dive a little bit deeper. You can throw out, hey, modify what you're doing like this, and I'm happy to sort of guide some of my demos to whatever people say. So really thrilled to have to be giving this talk. I'm just a quick little background personally. I'm one of the co-founders of a startup called Continual. You can go check us out at continual.ai. We're actually not currently doing a lot of things around generative AI, but generative AI generally is one of the most exciting areas of machine learning right now. The potentials are really mind-boggling. At least that's my impression. And so we're thinking about how do we enable people to do generative AI? What are the tools that machine learning engineers, machine learning teams need to productionize these models? And so we're doing a lot of work on that. Not all of it's available, currently on our website. But if you are interested in it, you're welcome to reach out. I'll give my email at the end, and I can happy to chat much more about that. Today, what I want to talk about is just give people a tour of what is this thing called generative AI. Why is it so exciting? What works, what doesn't work? And hopefully by the end of the talk, you'll gain a sort of intuition, if you don't already have it, for what these generative models can do, what maybe they can't do, and what are the workarounds to work around some of the problems that currently exist. What are the ways to maybe take these generative models and actually make them much more powerful than you might have originally thought, and just have a discussion around that. So I will do this with some set of slides, talk a little bit about the literature, some set of interactive demos, which I think really kind of make it much more tangible. We'll treat this informally. So hopefully by the end, you'll have learned at least one thing. Maybe some of you will have already experimented a lot with these models, and maybe for others of you here, this is all just brand new. So with that, let me get started. I'm also looking at the questions here, the style of my clients with generative AI. So a lot of people are interested in the visual domain, generate wonderful and meaningful documentation for technical processes. That's actually a fantastic use case. Somebody on our team actually did a use case like that recently, and the results actually were pretty powerful. All right, so let me jump in by sharing my screen. So give me a moment here. All right, so hopefully everybody can see my screen, and I'm just gonna drop over back to the chat to make sure that I don't get this whole presentation without anybody seeing. So can somebody say, hey, Tristan, I can see your screen. I think everybody can see the chat here. Are we thumbs up? I think we're thumbs up. We can see it. All right, we're live. This is live for real. Okay, so today I want to talk about automating knowledge work with generative AI. I think you could also say creative work or augmenting, sort of human creativity and human knowledge with generative AI. And I want to just sort of give a tour of that. So how are we going to do this? I'm going to do it informally. Let's have some fun. So if you haven't already introduced yourself in the chat, please do so. Say where you're from in the chat. There's already lots of people who have done that. Definitely put a generative AI use case that you're interested in the chat. I think it will give everybody else sort of a set of ideas for what generative AI, if you already know what generative AI is, what are some use cases that folks are thinking about. We can all start brainstorming together. And then throughout this presentation, please use the chat to drop in a question. So if you have something like, hey, when I say something, what did you mean by that? Maybe it was a little bit big. Put your questions in the chat. I might try switching back from time to time to the where I can see the chat. Unfortunately, I can't see the chat live while I'm giving this presentation. So worst case, at the end, we'll have plenty of time to do questions, and I'd love to be able to just sort of dive into what's on people's minds, talk about things that maybe aren't even part of this presentation. The space of generative AI is moving at a tremendous velocity, and today I just going to give you a little sample, but of some aspects, some papers, some demos of doing generative AI, particularly in the text domain. But there's other domains. The visual domain, I've already seen some questions in the chat around people who are interested in the visual domain. I've got a little demo over here, Playground AI, where we can experiment with some visual models and get a feel for that. And I'm happy to talk more about how those types of models, things like DALL-E, Stable Diffusion, et cetera, how they work, and some of the strengths and weaknesses currently that they have, and where maybe that world is going. So happy to address that at the end. So with that, what is generative AI? And rather than me give a definition, I would say, why don't we ask AI or generative AI what generative AI is? So I think one of the I have a few different sort of tools that I've got up here on my tabs that I can kind of use to sort of demonstrate generative AI products, or generate either for developers or for consumers or for knowledge workers. And this particular product, I've got my thing zoomed in here, is called character.ai. And it's a sort of nice example of a chatbot interface that is using behind the scenes generative AI techniques. And the team that's behind this, it's a very early product. The team that's behind this is actually the team that was behind Google's Lambda project, which many of you may know. So let's see, this is my interface. Oh, I'm gonna click in here. So I've created a bot here, and I'm just gonna start a new chat with it. And it says, hi, I'm a bot created by Tristan to help him build a presentation for the Toronto Machine Learning Summit on generative AI. How can I help you? This took me about 2-3 minutes to build. Basically, I just wrote this text. But now I have this bot. I don't know what it can do, but let's see. So the first thing I'm going to ask it is, what is generative AI? Let's see how it goes. So you might be familiar with tools like Alexa, right? They can say, play the music, what time is it? Maybe it can do some rudimentary types of sort of free text response. One of the really powerful capabilities of generative AI is the ability to generate these free form text about almost virtually any topic that you could imagine. So here I said, what is generative AI? And DaVinci, what the name of this tool that I called it, said generative AI, also known as generative machine learning, is a field of artificial intelligence focused on generating new content, such as images and text, using deep learning. This new content can be used for a wide variety of applications, ranging from artistic and creative pursuits to solving complex problems in scientific and technical fields. So I think first thing to recognize is, wow, it knew about generative AI. So I have not told this model anything. All I've done is said, essentially inputted that this is the goal of this bot. I've not taught it about generative AI or for instance, given it this particular bit of information. It just knew this, and we'll talk about how it knew this in a second. It also, I would say, one thing to note is that's a remarkably fluent sentence, right? So maybe it's not the depth that you wanted. Maybe you wanted a more technical explanation, but in terms of the grammatical syntax, very, very fluent. So we can try to dive a little bit deeper. You could say something like, okay, well, how is generative AI different than traditional machine learning? And see what it says. Traditional machine learning it uses a predefined data set of inputs to learn from and produce outputs. This is known as supervised learning. That kind of makes sense, right? With supervised learning, you have a label that you're trying to predict. Generative machine learning, on the other hand, generates its own inputs from random noise. Maybe not true, although it'd be interesting to know what it's thinking there, and making it unsupervised learning. This difference is what makes generative AI ideal for creation of new content, right? Then you could say something like explain it, that's a little vague. Explain it to an ML expert. Or maybe I'll say, I'm an ML expert. Can you give me more details? And who knows? It's interesting to see where I actually haven't written this question before. This particular one, this is a little vague. It kind of generates different responses each time. So it's always interesting to see where it shines, where these models shine, and where they maybe struggle or become repetitive, right? This is, I think, as you'll start to work with these models, I think you'll realize that some things completely are mind-blowing, at least to me, coming from a more traditional machine learning background, and other things are frustrating, where you'll get stuck in loops. So it says here in this case, it's saying, sure, let's use the example of generative AI text generation. Okay, we're going to do a lot of that. As you probably know, traditional machine learning algorithms use data to learn and improve. With regards to text generation, these algorithms are given data sets of human written content and are trained to create new content by analyzing patterns in the training data to produce results. That's actually a fantastic explanation. So generative AI, as well, I'll talk about it in a little bit, the way it works is it looks at a tremendous amount of data that exists in the world. That's typically, for instance, the whole internet, or a large portion of the internet, or a large portion of written text content. And we train a very, very large model to basically predict what missing words are, or what's next in a sentence. And we block out the sentence. How would we complete that sentence? What it's effectively doing is saying, how would I create, or at least at the base level, how would I create content similar to the content that I've seen? And what generative AI models, what we've realized over the last few years is if we take powerful new algorithms, things like the transformer architecture of models, we take tremendous amounts of data, right? For instance, the internet, and then we harness a tremendous amount of compute, thousands of GPUs working over weeks. The results are what you're seeing here. The results are, or maybe the found, as I'll talk about a little bit, this is a little bit more than what I just described. But the results, at least, are the foundation that are going to enable applications to be built like this. So you can see here, I'm halfway through here, then it says generative AI, on the other hand, does not require any training data. And the content it produces is created from random noise or by being guided by human input. So this is actually interesting. I thought that it was giving me a bad answer here, but that's actually not true. So what it's saying here is, as you'll see, there's really two ways. So once you've trained a model, which definitely requires data, you then can use it without actual data, with what's called a prompt. Or in the case, well, then you're saying, what about random noise? In the case of image models, models that you may have heard of, like DALL-E, OpenAI's DALL-E, or Stable Diffusion, those models actually work with a denoising process. So the diffusion models actually work with a denoising process. So here it's getting a little bit technical, which can be confusing because it's giving you a technical, in order to understand this, you need to understand how these models work. But what it's saying is we can generate a little bit of random noise, and then from that random noise, we can guide that random noise up into a generative image. That's a little bit, may not be intuitive to you currently, but that's what it's talking about there. And it says the result is a unique style or flavor only achieved by generative AI. So that right there, to me at least, was pretty remarkable. Let's go back and try to understand this a little bit more. So that's an example of a generative AI use case, in that case, a chatbot. Generative AI doesn't have to be a chatbot, but you're seeing that there's a very free-form set of text that's being generative, which is why I would classify that as a generative AI model. But how did that actually work, right? That seems like, wow, that must have, if you're not familiar with generative AI, if you're just doing regression and classification type use cases, forecasting, you might think, wow, that seems remarkably hard to do. What's actually, I think, one of the more remarkable aspects about the current models that exist is that use case, or at least something that approximates that use case, is actually much easier to implement than it is even to do something like regression, where you might have to do feature engineering, collect your data, train a model, etc. What do I mean by that? Well, let me show you quickly how you could build a chatbot using one of these large generative models. So one of the most dominant or popular large generative models that are out there is from OpenAI, a model called GTP3. And you can, if you want to play around with GTP3, all of these tools you can play around with are all public currently. You can go to OpenAI and sign up, and you will come into what they call their playground environment. This playground environment has a text box, and all you need to do is write some text, and then this model will try to come up with a completion for this text. A natural completion for that would a sentence that might follow the initial prefix, or what's called the prompt for this text. So what's remarkable about generative AI models is that you can be very clever about your prompting. And one thing that you can do, and a lot of people have demonstrated, is, okay, well, chat interfaces are a common interface that people like interacting with, or it's natural, right? We all use human dialogue to chat with one another. And so a natural thing to think is, well, how would I build sort of a chat interface? As you'll see, this is absolutely not the only thing that you can do with this. So all you need to do to build a chat interface is to think of the text that, if you had a natural completion, would form a dialogue. And so, for instance, let's actually look over here and say something. What do they have up here? I said, I'm a bot created by Tristan. So you could say something like, let me just type it in from scratch. So I'm just going to say, the following is a conversation between a human and a super smart AI. The goal of the AI is to answer the human's questions and be helpful. For instance, then let's give it an example so that it kind of knows what it would do. So we'd say, for instance, question, who is the president of the United States? Answer, Joe Biden. Okay. Now I can say, question, what is generative AI? Now, what's a little bit interesting is generative AI is a new concept, so I'm actually not convinced it's going to do a great job here, but maybe it will guess, okay? And I'll talk about a little bit about that, the problem around up-to-date information in a second. So I have this prompt, and I can say answer. So what I've done here is I've implemented an instruction. I'll talk a little bit about whether this instruction formatting, but I've also implemented some examples here, and this is not, all models do not have this format. But there's essentially what I've done is this is the prompt, and I'm asking for a completion. And I give it an example, so it kind of says, okay, I kind of get what's going to go on here. What is generative AI? And I click submit. Oh, I got a training space there. And you can see, okay, generative AI is a type of AI that is used to generate new content and ideas. Okay. So if you imagine building a system now, you could imagine this is the prompt. You write this out. And then the user, well, let's say this is the prompt, and then up to here. The user then would type this in, right? You're just hiding this complexity behind there's a simple, REST API call here to do this completion. It's just one line, right? This is the prompt. The following is a conversation between a human, and then it will generate a return. And then the answer here, this additional text, which is the completion, now is an answer. If you wrap that in a user interface like this, you get a pretty powerful user experience. Now I could say something like question, explain that in more detail, please. And then say answer. I probably should have said human AI here to make this more aligned with my top, and click submit. And you can say, okay, it starts to expand upon this. Generative AI is a type of AI that is used to generate new content and ideas. This is the type of AI is often used for creative applications that are generating new images, music, and text. All right. So all of a sudden, from just this idea of completion, you can see how we can potentially generate a free-formed conversational agent. Okay. Now, this has some problems. Or it doesn't solve the whole thing. And so let's jump back into, but it kind of gives you a flavor for how this all works. So, well, what I just showed you was an actual example of another magical tool where I'm just completing text. And you're still probably, if you're not familiar with these models, you haven't read these papers, you're still going, well, what exactly is going on here? So let's talk a little bit more about what exactly is going on here. So this model that I just showed from OpenAI, there's a series of papers. They were starting with the GPT-1, GPT-2, and GPT-3 papers. This particular paper here from 2020, called Large Language Models Are Few-Shot Learners, was really the seminal paper around GPT-3. And this paper, well, oops, I forgot to actually say what this paper does. So here, now is intentional, but here's an example of, a different type of use case that we can do maybe to help us out, do some knowledge work. I meant to summarize what this paper actually said, but I forgot to put the top 3 points in here. And I'm kind of lazy. I don't really want to read this whole description to you all. So what I'm going to do actually is see if GPT itself can help me out with this knowledge task. Now, I'm doing this all with these manual tools, but imagine in your mind a future of a set of tools, in this case, a slide creation tool, for instance, that maybe had some of this capabilities built in. So in this case, here's a link to the actual underlying paper. I'll just create a new tab here. And I have this abstract. Oh, it looks kind of long. So it seems I don't really want to read that. So I'm going to jump over to my playground here. Forget this chatbot thing. I don't really want to do chatbots. Chatbots seem overrated. So why don't I actually just summarize, see if we can do something else. So in this case, I'm going to say, the following, please, give me the top 3 points from the following abstract. Okay. And I'll just copy and paste this in. I'm not even going to read it. And then I'm going to say top 3 points. I'm going to kind of say, okay, let me just, I don't know, this is prompt engineering as we'll talk about. I'm going to sort of put another bit like, what is it actually trying to do? Say top 3 points, and I'll say 1. I'm going to sort of start the list. Okay. So here what I'm doing, as you can see, I'm defining an instruction up here. Please give me the top 3 points for the following abstract. So this is all part of a context. And then I'm sort of setting up how I would like, if you were a human and you looked at this, you probably would write 1, 2, 3. Okay. There's no guarantee, right? I could have done a dash. That I'm going to do this. Okay. So one of the amazing things about generative AI is that it can sort of infer, how you want things from your instructions like this. It can infer how you want to complete things, but it is certainly up to you to try to be as explicit as possible about how you want to complete things. And there's no guarantee that you're going to complete things in the right way, right? So there's no structure here. All this model is a model that goes from input text. to a completion of that input text, okay? It just tries to complete it in a way that is aligned or with how hopefully the human being thinks the text should be completed, right? Because that will make it useful. Turns out you can do a lot of things. I just showed you a chatbot with this analogy, and now I'm showing a summarization thing. So here, let's see if it works. So here it says, 3 points. Large language models can improve task-agnostic few-shot performance. Okay, so what it's saying there is large language models, these models that are trained on huge amounts of information, can improve the task agnostic, so multitask, not a specific task, but many different tasks, right? I built a chat bot and not. And then few shot performance. Well, we don't really talk about few shot performance yet. We're actually kind of doing what's called instructions here, following here. But we'll get to few shot performance, or what few shot means, or zero shot, few shot means in a second. But it's saying, hey, these large language models can do pretty darn good job at that. So we might want to see if that's true. And then it says the model can be applied without any gradient updates or fine tuning. What that means is that in order to do a particular use case, we're not actually having to update or fine tune this model. And then it says finally, the model can generate samples of news articles which human evaluators have difficulty distinguishing from articles written by humans. And that's somewhere probably in, you can see it's sort of summarizing something. It thinks this down here is an important sentence there. So, okay, so it's telling me, wait, it can't just do chatbots. It can't just do summarization. It can actually generate whole articles. Okay, so interesting. Let's copy this over to my thing just so I have this as a reference point. I'm just going to edit these slides, okay, just so I have it here for myself. Probably should format it better. Okay, so what's the first one? Model can improve task agnostic on few shot performance. Okay, so what do we mean by and then a model can be applied without any gradient updates or fine tuning. So what's saying is we can do a bunch of tasks, okay? And let me try a task. Okay, let me try a task. So a task that I might want to do is, let's say that I'm doing reviews for something. So I could go over here, and I want to maybe like classify the reviews. I'm going to go to Yelp, and let me just see. I don't know if I'm logged in, but I'm going to search for pizza because I like pizza. And I'm just trying to get myself a nice review. Mountain Mike's Pizza. It's actually not the best pizza place in Oakland here, but I'll click on it, and let's see. I'll go to a review. Do we have a nice people who go to Mountain Mike's don't go that much. So let me just grab this this review. Now here you can start to just see a few different things. First of all, there are some classifications that Yelp is building into its product. It's saying, is this useful? Is it funny? Is it cool? Right? Those are some classification. It's also doing, you may not see it, right, but I would say it's doing a lot of content moderation, right? Unfortunately, right, this is a user-generated content site, so people don't always say the nicest things. And while you might want a bad review, at some point it kind of crosses the line where you probably want to actually not have it on the site. It's great, nobody benefits from having it on the site. So there's with these reviews, there's a lot of things that you might want to do. You might want to say, is this positive or negative, right? Because maybe the person didn't, actually write a star. You might want to say, is it useful? Is it funny? Is it cool? Okay. So now, traditionally, you would have to, if you were doing this, you'd have to create a whole data set, collect all these, all these reviews, create a set of classifier of labels, train a bunch of models, honestly maintain those models. It's actually a pretty hard task prior to these transformers or BERT models, because text understanding, you look for keywords and but you don't understand the word not. So then we got transformer models that did better. Well, hey, I don't have time for any of that. So one of the the claims of this particular paper, the GTP paper, is that I don't need to do any of that. I can actually do it with just, a few shots or 0 shots. So what's an example of that? Let me just see if I can do this. I'll just create this review, and I'll say the following is a review on Yelp. Please answer, classify, and then say something. Please answer if this review is positive or negative. and say why. All right. I do answer. Let's see what happens. I might have, that's not the best prompt. It's a little bit vague in terms of what this review is positive because the person enjoyed the pizza and liked the way that there were many coupon codes to choose from, right? So you could think of that, or you could think, okay, that's a positive, or just say, please answer if this review was positive or negative, and maybe I'll just say in one word, and then I'll say positive, negative, maybe because I'm just actually trying to fill out that count there, right? So this was a little bit too long. I'd still have to parse it. Let's see what it does there. Positive. Boom. I've just built a classifier, right? You could say something like, question, is this review offensive? Okay. Maybe you want to do content moderation. You could say answer. No, this review is not. Maybe I should say, this is an example where you need to be more explicit about the task. This would still require me to parse yes or no. So say answer yes or no in one word. Okay. Then I'll do this. Oops. And well, it says no, generally doesn't like spaces after it. It gives better result if there's not spaces for a technical reason, which is the warning on the bottom. And so it says no here. Question. Now, that's great. So I've just, well, who knows how good this is? I mean, you have to do this on a bunch of reviews and get some ground truth and see how things are. But that's pretty remarkable that we seem to be getting an answer, some basic content moderation. I haven't trained any, this is really what would be called zero shot. I haven't trained any model. I've given it one example and I've simply asked the question on it. And we'll talk about the different ways to do these prompts in a second. But you might even want to do something like, let's say that it occasionally says yes. Maybe we actually want to understand the rationale, right? Model explainability. Why does this model think that this is a particularly offensive review? And so we could say, question, why? Maybe we do it all, why do you think that? I don't know if this will work. I haven't done this before, but let's see. And I'll click answer. The review is not offensive because it is a review of the food and it is not of the restaurant or the service. Okay, seems probably true. Again, you'd have to, gain confidence here. I'm just kind of, glancing at this. You'd have to gain confidence of this, create some sort of golden data set, sort of say, hey, how does this model do? Maybe experiment with different prompts, see the performance of that, right? So to productionize this model, incredibly easy to actually put it into production, right? All you need to do is, grab this code, parse this up a little bit, and you've just built a classifier, you built an explainer, you potentially built a moderation interface as a result of this, and of course you can also enrich your information, right? Is this helpful? What is the top? Summarize this in one line, right? Summarize review in one line, right? Maybe there's search results you want. So I'll say something like this. And let's see if the review liked that there were many coupon codes to choose from and that the pizza place was reasonably priced. So maybe I'll just take that. They were disappointed with the heart pizza that they ordered on Valentine's Day. Is that true? Did they actually do? Wow, they did order it on Valentine's Day. Okay, pretty cool. Now you might want to, you can see here the reviewer, you might want to just, say, give it a few examples of the types of summaries that you want to write. So this is an example of where I'm getting great results, but you often kind of realize, hey, this is maybe not the exact type of generative result that I would want in my search results. Maybe I want something a little bit more pithy, or quoted, or versus summarized. And so a lot of what you'll see with these generative models is you have to play a lot with this. But what's remarkable here is I'm accomplishing a tremendous amount, right, in the 33 minutes that I've been talking so far. Okay, we're just getting started. Let's go a little further in. Okay. We can say without any gradient methods being applied here, that just means that, look, we've done no fine tuning. We haven't done anything there. And the final claim that is it can actually do things that are more complicated than this. It can actually generate news articles that human evaluators have difficulty distinguishing from articles written by humans. In the chat, I think when we were just getting started, somebody mentioned this as a potential use case. And so we can just quickly see if this is, at all plausible. We'll jump back into the playground here. And, at Continual, we're basically building a sort of an operational AI platform. We're super interested in machine learning operations, productionization of these types of models and other types of models, and how to do that. So, you could imagine that I might want to write a blog article on, introduction to machine learning operations. So I write a blog on let's call it ML ops. And, I actually have an opinion. I want to have some of my own opinions here. So I have, sort of an opinion that machine learning operations and the machine learning life cycle really has 3 phases. Make sure to cover experiment management, right, which is the development part of the task where you're working and iterating on a model, right, trying these different prompts. Let me do release management. I actually think once you're with a team, you really need to think about how you're going to deploy these models. Is this model better? Is it not, doing things that I don't want to do, generating offensive content, for instance? So you want to do release management, right? Maybe hook up CI/CD. And then you ultimately, once the model is deployed, you want to do performance management. At least that's my perception, right? I want this to be an article that's a little bit, not just completely generic performance management. And so I'll say title and modern approach to ML ops by Tristan Zajonc. And then let's see what happens. The world of machine learning is evolving rapidly with technologies and tools that have developed all the time. It can be difficult to keep up. Fortunately, there is a new approach to machine learning ops that can help. It seems a little bit overhyped, but I could probably modify that. This approach, called MLOps, is a modern way to manage the life cycle of machine learning models. It includes experiment management, release management, and performance management. By using MLOps, organizations can streamline the process of developing and deploying machine learning models. MLOps can help organize to automate the process of experiment management, optimize the process of release management, and improve the performance of machine learning models. And then it goes on. Maybe I'll create some sections. So I'll delete this and I'll say, let's talk about experiment management. What is experiment management? And I'll click next. Here I'm using incredibly raw tools here, right? I'm using developer tools. This is not the way that you would typically write things. Somebody should build a writing tool that's powered by this, but it gives you the sense of what is possible. And so here you can see it just wrote out the remainder of this. It's a pretty lightweight blog. It's not totally clear to me how to get it to go a little bit deeper, become more expert, but it's doing at least a first pass, right? It's saying experiment management is tracking and managing experiments, release management, the processing of managing release to new versions of software. In the context of machine learning, this is new versions of machine learning models. I mean, it's pretty much correct, right? What would you do in this aspect? You'd automate the process of release new versions. That's CI/CD. Coordinate release versions, right? Your team, who does the approvals, and then test them, right? Put them into actually have a formalized testing process. Have a golden test set to say, does the quality of these models perform better than previously? And then it goes on and on. Okay, so the final claim here is that it can generate news articles indistinguishable from humans. Well, I mean, that was a pretty rough blog, but maybe they did some more stuff where they really prompted it, gave it a lot of examples. What do I mean by prompting it? In most of these examples, I'm giving it an instruction with no prompts. And then you hear this sort of few-shot idea here in the title where it says few-shot learners. So most of you have probably kind of getting a sense for this or already are aware of this, but just to kind of recap, this is an image from this paper. One of the key aspects or goals of in generative AI, one of the key things that is still left up to all of us is how do I guide or align these models with my preferences? How do I express my preferences, right? I'm saying write a machine learning ops article, but for who? Right, in the style of New York Times, the New Yorker, right, where it's all for the layperson, the New Yorker, where it's maybe some human story, a technical blog where we're going to really go into the technical details and talk about the tools. That details of that, we still need to figure out how do we communicate that with the underlying model, right? How do we give the model enough information so it knows what we want it to do so that it can at least try? It still may fail, right? The model still may not be powerful enough. It may not have the information. It may not have the logical reasoning capabilities to do it. But even if it did, even if we had a super intelligence, let's say, in terms of a model, we would still need to be able to communicate with that model and tell it what we wanted to do. So there's a few different ways to do this that are common. Zero-shot reasoning means we basically describe the task without any examples, and you simply say, translate, for instance, English to French here, and then you give cheese, and then you give an example. and it should just hopefully complete that. And then honestly, a human for a simple task like this, a human does a pretty good job. And in fact, as you've seen, I haven't really been giving many examples, and these models are doing a pretty good job. These models can do a lot better if you give them a couple examples, right? So instructions are one way to, as we'll talk about a little bit, are one way to guide these models. But another way to guide these models is actually to give a set of examples. And so to say, translate English to French, and then say sea otter to l'autre de mer, which I guess is the way you say that in French, right? And then you say cheese and fromage or whatever it is in French. You can do more of those. You're effectively giving it training samples, but the critical thing to recognize here is you're giving it training samples. They are not used during training. They are used as features or inputs to the forward path of a generative model, right? So we are not doing gradient updates to this point of what this model said right here. The model does not do gradient updates or fine tuning. It instead, during the forward path of the model, it uses these examples to quickly learn, right, with 0, 1, or 2 or 3 examples, what the pattern is here, and then it becomes very good at completing. So with just a couple examples, because it understands the background of the world, it can now generate these things. This contrasts with a world of fine-tuning, right? Maybe a couple of years ago, we were all excited about BERT, and the typical thing we would do in that world, right, is we take BERT, which would kind of have us understand language better, so it's still pre-training. But then what we would do is we would still fine-tune that model in some way, right? We would give it a set of examples, and then we'd update all the weights in those models so that the model was better at predicting or reducing the loss or predicting the outcomes, the labels that we had, the ground truth labels that we had. And so in this world, the beautiful thing is that we don't need to do any of that. And what that means is, hey, we can just get going really, 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 really quickly and actually get pretty good results. So we'll give me 1 second here. Was I gonna? This doesn't. Okay, so let's talk a few. We've seen a lot of exciting things so far. It's not all rosy, and so let's talk about a few of the problems, and then let's talk about some of the ways that we can work around them. So one of the problems that with large language models that people have found, and if you read these papers, even the paper that we were just looking at there, the original GPT-3 paper, is it will say that, hey, it doesn't do that well at, for instance, mathematics, right? These complex reasoning tasks. And you can see to see an example of this actually, let me just quickly show you, let me just quickly see if I can think of an example. So, answer the following question. And question, let's say a bike and a motorcycle and a car are 30. This is kind of a classic word problem, right? Are 60 miles apart. Let's see if we can do this in our minds. The car travels at 60 miles per hour towards the motorcycle, which is traveling toward the car at 30 miles per hour. Okay, so it's going twice as fast. Okay. Well, what is, how much farther has the car traveled? Oops. By the time the car and motorcycle meet. Okay, so this is probably a type of question, hopefully I'm not going to humiliate myself here, that a human could, probably a high school student could answer, right? It's kind of a word problem, you turn it into some algebra, or you have some intuition. For me, I would say, okay, it's traveling twice as far. They're heading towards each other, and the car is traveling twice as fast as the motorcycle, and so it's probably going to go twice the distance. And there's, it could do that in an hour, so we can see this. Okay, so not right. The car has traveled 90 miles when it meets the motorcycle. So very unclear what is the reasoning here that it's doing. Now, not only is it not the right answer, although unless I have a typo here, but I don't even think I do, right? They're traveling towards each other, right? And they're going 60 miles an hour, so the car itself could go the whole 60 miles in that 1 hour. So it's giving me the wrong answer. It's not only giving me the wrong answer, it's actually also, I think what's unfortunate here is it's giving me the wrong answer, and it's not saying that, right? So it's being confident. And this is one of the big downsides of language models. Not only do they often not know things, but when they don't know things, they're often very confident about not knowing things, okay? And so that's not great. Now, okay, I'm doing a zero-shot example here. It's the hardest example. I could give it a number of other examples, and maybe it would do a better job. So I probably could do a little bit better here. And they're actually, one of the things that has happened, so, how do we potentially solve this? One of the things that's happened is a lot of people have spent the last year or two kind of coming up with very kind of clever, lightweight ways to improve large language models without actually retraining them or building bigger models. And a few, just to kind of give you an intuition for how this works, what you need to do is you need to sort of help the language model achieve your task, right? And so here's a paper that came out, which was a very influential paper called Chain of Thought. And the original OpenAI paper basically said, look, we're not particularly good at these types of problems. We don't know exactly how we're going to solve them. I mean, we are better than we would have thought, but we still fail on a lot of these types of word problems and logical problems, math problems. And then this paper came along and said, hey, actually, if you don't just give it an answer, so standard prompting here would basically say, hey, give a question, example prompt. This would be a one-shot prompt. You'd say, give a prompt that's a word problem, and then just say, the answer is X, right? And then say question, your new question, like the one I just gave, and your answer is, and then it would say, the model would say the answer is 27, incorrect, okay? Chain of thought prompting is simply saying, hey, we happen to try this other way of prompting. Take that same input that you had, that word problem, but rather than just give the answer, explain your chain of thought that you had as a human to give that answer. So give it an example where you're thinking step by step about how you're doing that, right? So in this case, it says, there's a thing that says Roger started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls, 5 plus 6 is 11. The answer is therefore 11. And so what you're seeing here is a chain of thought that you give in as example. And then as a result, at least in what this particular paper claims, is that by doing this, these models perform dramatically better, okay? In fact, it's better than this, better than a whole bunch of benchmarks that happened. This is an example of what's called prompt engineering. It's sort of saying, rather than sort of you're doing engineering of the actual model and the model architecture, what you're actually doing is you're just trying to think about your, intuition about how you can sort of tune these prompts in a way that, makes these models perform better. And what's remarkable is that these models can perform remarkably better following these approaches. Another example of this is that's even sort of a more radical version. The intuition of this paper was, hey, we can use chain of thought, and these models perform much better with a chain of thought. But you still have to give it some examples of this chain of thought. A paper came out, and this is kind of one of these remarkable examples of all you needed to do, publishing a paper on an incredibly simple idea, where all they did was they said, here's basically a few shot example, which is what that previous paper said. Then they said few shot chain of thought, COT means chain of thought. They said, actually, what we can do is a zero shot chain of thought. And all we're going to do for a zero shot chain of thought is to add the words, let's think step by step, okay? And prefix that to the answer. What they mean here is all they're going to do here is remove this. And I don't actually think this is going to work in this particular case. But if you do this on a benchmark of many similar type problems, it will work. So you say, let's think step by step. You make that part of the prompt. What you're doing here is you're encouraging the model to do the completion bit by bit, to maybe summarize some information that's going to be relevant. Think through the steps, right? Because what these models are doing are saying, what is the most likely thing to happen next? Rather than try to answer the whole question all in one, which requires a very complex reasoning over this, why not allow it to kind of do that completion in a way where first it tries to sort of maybe find the salient bits of this. And so if I do the example here, travel to combined. So the answer, you can see it's trying to think this step by step, and you can see here's why these models, one of the big gaps of these models it's trying to say a car has traveled 60 miles. Well, why? That's not true. I mean, it does travel 60 miles an hour. The motorcycle has traveled 30 miles. Therefore, they've compiled to try and combine 90 miles. Not correct. Okay, they're driving at each other. If you read this question carefully, when do they meet? But there's a lot of subtle, implicit domain knowledge about the world that a human needs to understand, right? Around going towards one another, right? Geography, and things like that to work this out. And in this case, this model is failing. So these models are great, but not currently really solving this in a reliable way. Although there are some of these ideas like let's think step by step, and prompt engineering that can do dramatically better, right? I could probably do even better on this by giving it more examples of correctly answered word problems. I'm doing completely zero shot here. And so there's a lot of other prompt engineering I could do. And I think one of the things, if you're thinking about automating knowledge work or just work in general, building these into your applications, this type of use case, you're going to spend a lot of time at least in the current state of the art of these models, doing this sort of work. Okay, let's move on. So what we're just basically been seeing is examples of prompt engineering. So what are the advantages of prompt engineering and what are some of the cons? Pros. The benefits of prompt engineering, incredibly flexible. In fact, much more flexible than you might initially think. You can do things like classification, question answering bots, writing a document, pull entity extraction, all this by thinking about word problems, even by thinking about clever ways to do your prompting and to set these things up either with few shot examples, with kind of instructions that are being followed. And all that really requires is you to manipulate a text field and think about, if I did the text in the prompt one way, how would I complete the things? It's very fast to get an initial working benchmark. There's no data or training. I think once you start interacting with this model, this really sinks in as, wow, this makes my life so much easier when I'm not thinking about pipelines to train things. It's also actually, once you're starting to think about productionization, it's very simple to deploy. Provided, of course, that you're not, deploying these large language models yourself. If you're using maybe one of the open source models that are available, for instance, on Hugging Face. The benefit, why is it simple to deploy? Well, one, there's many hosted offerings that you can use, but more important, it's one model for many use cases. So you're not actually having to deploy a separate model that's been fine-tuned, that has a whole life cycle. You're just maintaining the life cycle, in this case, you could think of the features of a model, which include the prompt, right? So the prompt basically defines the model version or a particular use case. That is just a string that you can store in a database that you can put in your code, right? You might still need to track the performance of that string and manage the life cycle of it, but there's no training involved, right? There's no infrastructure that's deployed. You're hitting one model endpoint that says text in, text out. It's a very simple interface. It's flexible. And a final one, which I think is very actually important as we talk about other ways to guide these models, is that prompt engineering is privacy preserving. What I mean by that is many real world use cases are operating on proprietary data of your customers. If you're building a product, right, you might want to be working on support case data, or you might want to be working on emails, or you might be working on internal documents. Prompt engineering never exposes that data to the training process of the model, where some of that data sort of may get incorporated into the models, and you may have loose guarantees without a lot of work around, federated learning or sort of privacy protected learning. You may have a hard time to guarantee that information is not leaking into the model parameters and then potentially being exposed by an attack, that could actually, sort of write out the email or the social security number of that you trained on, if you trained on that customer data. And so it does that by saying, no, it's the information is only in the prompt. It's only a feature, right? It's not an actual input to the training process. The cons of prompt engineering is it can be a dark art. As you'll see when you get in this world, there's a million things to do. Also, the prompting context is limited. So in the current models, there's around 4,000 tokens. Think of tokens like a subpart of a word or a character, a little more than a character. But essentially, these models, the context of the model, the prompt context can only be 4,000 tokens long. Which does become challenging. For instance, if you say summarize a book, right, you can't put the whole book in there. And so what then you'll have to think about, okay, well, how would I summarize a book? And you'll have to sort of break that book apart and into 4,000 character chunks and maybe summarize those chunks and then summarize a set of concatenation of chunks and sort of do a map reduce of summarizations. So there's often ways to work around these ideas or these limits. But it will require sort of more work. Large multitasking models like these OpenAI models that I've been demonstrating are also slow, and they can be expensive. And I would say one other downside, I think, of prompt engineering, if you go too deep in here, is that it's unclear. This world is moving so fast. And so the future models that come out may make this work irrelevant, right? There may be different, this may be a sort of a stepping point that we are, where prompt engineering is still very important to get good performance out of these models, but that might not be the case a year from now. So this whole world is moving extremely fast, but definitely prompt engineering is at the core of making these models work. All right, so what's number two? Problem number two is, and this is sort of a deeper version of what we were just saying, is that large language models are not inherently aligned with our goals. And for those of you who haven't heard this term aligned is a term that is often used in the world of, artificial intelligence to mean, is the AI doing or following the goals of the human? Sometimes people are doing this in the sense of there's AI going to take over the world, and or we're going to have Skynet. But there's actually, even if you put aside that, which is not an imminent thing that's going to happen, there's an alignment problem still around there's nothing that we're doing in this basic idea of text completion that is causing language models to follow the goals of the human being that we have, like to write a very informative article on machine learning operations. Instead, with these language models at the base, when they're just trained in terms of filling in or completing text, if that's the objective, the goal of them is to complete the text in a way that's most similar to the text that would have been found on the internet, for good or for bad. So if your training data includes a lot of offensive content, very well, you could get a lot of offensive content. It includes a lot of stereotypical content. You could have a lot of stereotypes entering your generations. If it includes, and it also just kind of behaves in a weird way, right? It doesn't behave. What I've been showing you actually is models, as I'll discuss, that are instruction fine-tuned, but that actually isn't. That's a separate process that tries to align models with following instructions, which I'll talk about. So to talk a little bit about this idea, because I think what you've been seeing so far is me typing things in and it's been following instructions. What is the difference between a model that has that characteristic and doesn't have that characteristic? And then how does this instruction fine-tuning or these instruction following large language models work, which are a refinement of large language models that are different than just trying to complete text in a way that's similar to the internet. So to show you an example of this, there's another tool called Cohere. And Cohere, the benefit of it is it has a simple model that is not instruction fine-tuned. It is simply trained on a large corpus of data, and it will essentially complete the text input that you give, the prompt that you give, in a way that is most likely to text that you would find on the internet. Okay, and so let's redo that MLOps example where I'm trying to write an MLOps blog. And so I might very naturally write a prompt like this, where I say, write a blog introducing MLOps. Okay, and I won't do more than that. And I'll say generate, and we'll see what happens. So here we got a completion that says, write a blog introducing MLOps. And then it says, use a service such as Canva to create eye-catching graphic to accompany your blog post. You can download the template from Canva for the training materials section. Now that you have completed the lab, you will see, okay. So what's going on here, right here? This example, I don't know, it sort of sounds like maybe it's a website marketing copy that it's doing, right? It's like maybe a sentence like write a blog introducing MLOps, and there's a marketing website out there that's saying, hey, you can write your blog faster in tools like Canva, or you should augment your blog with eye-catching graphics. So it's not following the instruction. What it's doing is it's saying, if I see a sentence like this, what sentence is most likely to follow? Okay, and you'll see very weird results like this for these. This is a large language model that is simply trained on, I'm trying to complete text like the internet. And so here's an even more obvious example. It says, write a blog introducing MLOps. What is the completion? It says, write a blog introducing the flexible framework, write a blog introducing data science. It's saying, you don't see, when you see a thing like this, an instruction like this on the internet, you typically see a set of instructions which are not telling a model to do something. They're just saying like, maybe here's a good way to, get started writing about data science or something, right? Like that might be how, if you saw this sentence, what would follow from it. Now, that is not great, and that's the problem. Most open source large language models actually just have this idea of they're not fine-tuned to follow instructions, they're simply fine-tuned to complete text on the internet. And even if you curate that text to be better, it's still not great. So let's think about how this. So one of the nice things about Cohere is they've recently released what they call their command model, and this command model is fine-tuned in a way that I'll explain in a second to follow commands. And actually, that's very similar to what OpenAI's default models do, okay, which are actually critical to their high performance. And so if I switch the model here to this command extra large model, and I click generate here, you now will see an introductory paragraph here that says MLOps is a new way of working with machine learning that focuses on collaboration and communication between data scientists and engineers. It's a methodology that helps streamline the machine learning process and make it more efficient. Amazing, way, way, way better, right? This, just by changing this model, there's something about the internals of this model that is much easier for me to use, because now what I can do is I can say an instruction up top, and it will complete it in a way that is following that instruction. That is very different than simply saying following text. Okay, so how does that work? How was that achieved? So there's a few different ways this was achieved. The best paper here, if you're interested in this sort of how these command following models work, is this paper again from OpenAI called "Training Language Models to Follow Instructions with Human Feedback." There's another model that's on summarization that's also talking about this. And the net result, the takeaway here is that you can significantly improve models by iteratively tuning them on human feedback. And in particular, it would be nice if you could tune models that preserve their multitask nature. So in many cases, we're familiar with fine tuning, where we say, okay, we have a very specific task, like classification tasks. We'll fine tune on a set of classification. But one of the incredibly powerful things about these large language models is their ability to use many tasks, right, with zero-shot or few-shot examples. And so what OpenAI noticed here is that there's a general task, a task that actually can handle many, many examples, which is instruction following. If you follow instructions, if I type in my command and I see, hey, write a blog on MLOps, let's try to build a generative model, fine-tuned model to follow the instruction. So not to write blogs, but to follow instructions. And that instruction could be classify this text, right? Summarize this document, right? Like what I did, give me 3 bullet points, right? Those aren't completions that are like the internet. They're completions that are trying to follow the human instruction. And that's what's called alignment, aligning the models with this. And so OpenAI has this, it's now in their latest models, but they've talked a little bit about publicly of some of the public work. Whether they're doing exactly this with their private models is unclear. But the result that they report here is that a much smaller model, basically a 1.3 billion parameter model, they call this the instruct GP, I always get this flipped here, GPT model is preferred over a 175 billion parameter model, and so doing much better. How does this work? Really quickly, it goes through a three-step process. The first process here is you have a prompt, such as write a blog. You generate some canonical examples. Okay, so this is what would be called supervised. This is really creating a supervised a generative model. So you have a prompt like write an article. You have some labelers, write some blogs, or follow those instructions, right? I mean, hopefully the instructions aren't as long as writing a blog. And then you fine tune that GPT-3 model using supervised learning. That's step one. Then what they do is they say, hey, we need to expand that training set. And here's how we're going to do it. We're going to generate some synthetic data. So what we're going to do is we're first going to now use that prompt and use this original model to generate a bunch of answers. We're then going to do the task, which is a much easier task than actually writing the responses, of rating, do I like this answer or this answer better? Okay. And so you're going to collect some from some labelers, some from human labelers, which outputs are best and which outputs are worse. Now, from that, what you're going to do is you're going to train what's called the reward model. And that's a model that is effectively trying to build a model of human preferences. What do humans like, right? What do they like? What do they like? How do they like instructions to be followed? And so you're going to build that, what's called the reward model. It's an intermediate model. And then the final step, which is why this is called reinforcement learning, is you're going to do a reinforcement learning process where that reward model is effectively acting as the reward in a reinforcement learning loop, where what you're going to do is you're first going to take a new prompt. You're going to sample a prompt from the data set. You're going to then generate some output, okay? You're going to write a story. Then you're going to take your reward model that's going to be a stand-in for that human labeler so that you can scale this up, right? You can take a small number of labels and now scale this up to a lot of pseudo labels if you want to give it. It's going to give you the reward. The reward is, does the person prefer it or not? And you're going to use that reward, in a reinforcement learning algorithm. Here they're using something called proximal policy optimization, PPO, to actually fine-tune the parameters to generate a model that will lead to a higher reward in this reward model. And they actually loop this process again and again, so the model then gets better. They actually go back here and generate even better examples, generate a better reward model, flip this in. So there's also an outer loop. There's a loop that's going on here, which is fully automated. And there's a loop that's going on here, which requires human intervention. Okay. The downside of this is that it requires a lot of work. And so recently, you're doing only a lot of technical work, but also a lot of labels. There's other ways to do this that don't involve reinforcement learning. Reinforcement learning here is really scaling up the number of these labels and trying to kind of get a lot of information from a few, not a huge number of feedback points. Google has a recent paper literally published, last week called Scaling Instruction Fine-Tuned Models that takes a more supervised approach. And what they've fundamentally done is they've realized, hey, we can actually generate, using generative models, we can generate in a set of training data that have this instruction instruction following format, where we generate a massive amount of basically pairs of here's an instruction and here's a completion of that instruction, and they can be across a whole bunch of different tasks. And so in particular, they have over 1,800 tasks that are phrased as instructions, everything from machine translation to summarization to word problems, et cetera, that are curated. Both some of them are automatically generated, some of them are from data sets. They put this all into a big pot. They train a huge model, and they find that this model dramatically improves the human evaluations of performance, which is a very, very similar result to what the OpenAI model is. Okay, that all sounds super awesome. And you're saying, okay, let's get rid of prompt engineering. Why don't we all just do fine tuning? But let's think a little bit about the pros and cons before we go down this path. And so for fine tuning and instruction fine tuning, so fine tuning is for a particular use case, you're going to build a specific bespoke model for that use case. Instruction fine tuning is you're going to fine tune a model to follow instructions. It's still going to be a general multitask model. Let's think about the pros. So the pros is this is an incredibly powerful alignment tool. Not only can it build a model that's like, for instance, follows instructions and is much easier and nicer to interact with, but it can also be do things like reduce harmful outputs or offensive outputs. You can guide models, for instance, not perfectly, but to try to avoid some of the generations that you might want to avoid. So even if you did an instruction to say something offensive, you can, if you want, if that's your goal, you can for your use case, you can try to tune these models to actually not want to do that, right? So we still, even if the instruction is that, the reward model would still be negative, and the model it becomes harder and harder to generate that. The instruction fine-tuning models actually maintains the benefits of few-shot learning, right? So you're still having a very general model. And so I think that's why, at least if you're building, or for the companies that are building these general models, this idea of instruction fine-tuning is extremely appealing, much more appealing than fine-tuning, which is very hard to scale to many use cases, right? Because then you'll need a separate model deployed for every single individual use case, which can be very costly and a lot of sort of infrastructure work. One benefit of fine-tuning versus instruction fine-tuning is fine-tuning can make smaller models better, and those smaller models are also faster and they're cheaper. And so there are plenty of examples where fine-tuning these models is actually something that you would want to do, and then that's definitely a pro of fine-tuning. It does require a training process, pipeline, a pipeline. Although some of these models, like the OpenAI models, do have fine-tuning APIs. The cons are fine-tuning requires labels, right? So that's not always available and very expensive. Reinforcement learning with human feedback is not straightforward to implement currently. There's, maybe just starting to be some open source libraries that sort of implement this whole loop. So, it's really kind of in the research sphere. Still, there's not great tools that, that kind of give you that full workflow around it. It's often actually hard to evaluate quality. So if you think of an example like a book summary, right? Does a human know that the book summary is good without reading the book? Not really. And what's the way to know whether the quality is good? Well, you have to read that whole book very carefully and then look at 2 summaries. That's a very expensive and slow labeling task. And so actually one of the big open questions is basically how to solicit people's preferences on these tasks that are even hard for humans to give feedback on, because they're just sort of big tasks. So how do you sort of decompose that? There's some work that's called recursive reward modeling, if you're interested in that. Large fine-tuned models can be more expensive, so that's a con. I think in OpenAI's case, it's like 3 or 4 times more expensive. And then a final one, which I think is often underappreciated, but should be very front and center in your minds, is that for real-world examples, again, you often have customer data and you want to fine-tune on customer data, and you think, hey, I'll make my models better. But as soon as you start doing that, you have to think about privacy. Are you leaking data of the customer into your model parameters? And do those potentially in the world of generative AI, where it's not just going to give you a classifier where you kind of know that, hey, yes, the customer might not want my data shared, but maybe they're okay with it. To say, is this customer going to churn or something? That's no big deal. If there's some cross company, if you have it in your terms of service, that might not be a big deal. But for these generative models, the generative models are actually generating text, right? So you could say like, list out some common passwords for, the Bank of New York or something. And I don't know, if you happen to have fine-tuned on the model, it might actually have memorized that password, right? Or something like that. Or some internal, like what is the internal strategy of this company? And if you had that company internal and you had their emails, the model that the person that you generated might actually report back what the internal strategy is. So it becomes, in these generative cases, you have to be very careful when fine-tuning on customer data that you're not going to then expose it out to your users. Okay, but needless to say, fine-tuning, another alignment of models is a huge a challenge, a huge priority. There are ways, and fine-tuning and instruction fine-tuning is a way for us to deal with this. Okay, problem 3, the last major problem that we're going to chat about is large language models don't know lots of stuff and they make stuff up, right? So we saw a little bit about that make stuff up, or at least getting things wrong in that word problem. But they also just don't know stuff. And that's inherent to the way they're trained. And so to give you a quick example of this, if I jump in here and do our question answer bots, like let's say your question answer bot, and I'll say AI, this is not a great prompt, but I'll just do it because it's fast. And I'll say human, but or answer the following questions. Answer the following questions. Okay, and I'll say question, who is the president of the US? Okay, this is a pretty interesting, pretty simple, hopefully, and I'm not trying to be political here, hopefully question. And if I say answer, it will say, the president of the United States is Donald Trump. Now, what is going on here is not some political statement about the 2020 election. What is going on here is that this model was trained on data from the 2019 period and only has information in its parameters. It's kind of memorized bits of facts, and in these billions, 175 billion parameters, it's memorized some of these facts. It doesn't have access to external data. And so what it has is data as of 2019. So that's even probably not great for generative AI. Maybe it guessed what that term was, but it really, that's a term that's relatively modern. So it doesn't know a ton about this, okay? Other models, like if I go over here and I look at character.ai, I could say, an example, which is probably a different, I don't know what model is being used underneath the hood, but I say, for instance, who is the president of the United States? And let's see what it says. The current president of the United States is Joe Biden. He was elected on November 23rd, blah, blah, blah. They have a pretty good answer. So it seems like it's more up to date, and we don't know quite how that's doing that. We can kind of probe these models to see that by using very, very contemporaneous data. So for instance, like I say, who is the CEO of Twitter? That's something that's news, like a week old, right? Or a couple weeks old. And let's see what it says. The current CEO of Twitter is Parag Agrawal. That's not true, right? Elon Musk just bought Twitter. So it knew this information, had this information, but it seems like whether through some mechanism, we don't know how these models are trained or how they exactly work or what tools they use behind the scenes. It's not aware of the latest information. So this is, and you can also see that this statement is very used very specifically or confidently. So there are definitely searches. There's what are some ways to solve this? Probably the number one way to solve this is to augment large language models with external tools. And this actually is surprisingly easy to do. So this is a paper from DeepMind called Retro. It's improving large language models by retrieving trillions of tokens. The basic idea is you can train large language models to use external token-based databases and then augment the context of these models. They know how to go and query those databases. And by query, I simply mean they know how to this one basically it creates an embedding of the context that you currently have, the sentence that you currently have, and it goes up and it finds similar in a corpus of, for instance, the internet. It goes up and it finds similar sentences that are in that corpus, and then it augments the context of the large language models with that. This is a two-step process that you don't have to do anything particularly fancy to actually implement. But it's a very powerful way to add private data to models or to just add up-to-date information to models without actually retraining training particular models. And it's privacy preserving, unlike fine-tuning, because you're simply taking this information that you're getting from a search index and injecting it into the context, the prompt, and then the model can then use that information, that text information that you've added to the prompt to do things. You're not actually updating the model parameters. Okay. If you're wondering what embedding is, I think most people probably know, but here's an example of, like, for instance, a lot of questions in the Cohere interface. It's a whole bunch of questions. There's an embedding API, which is a little bit different than the generation APIs. And what it's doing is it's saying which of these text sentences are similar. Here's the two-dimensional representations of these embeddings. And you can see these questions like over here. When are you open? Are you open on weekends? When are you open? What are your hours? So these are things about your hours, right? Over here, can you accommodate groups? Can I bring a child? So it's like, do you have any baby seats? Do you have dessert? Do you have milkshakes? So this is around food. And so imagine if you were building a question answering bot. Well, you could augment it with search by creating an embedding of the question, doing a vector nearest neighbor search using one of the open source libraries out there into your, for instance, your knowledge base or your company documentation. And then taking a snippet or a couple snippets into this world and doing it and answering the question in a better way. Not only this is an example using vector search. You can also, OpenAI has a paper, very similar idea of using web search. So they partner probably with Microsoft, commercial search engine, to say, hey, rather than needing to fine tune these models every week to get up-to-date information, why don't we augment them with the ability to search the web? The way you do this is you just kind of prompt it in a way that if it doesn't know the answer to a question, you first do a search query. And it says, okay, search, and then what's the query? And then you take the query results and you paste it back into the context and you say, okay, answer the following question. But now you've enriched the context with information that is coming from a search. There's not a lot of engineering that needs to be done. And this is called, just this general idea of chaining together these models is called prompt chaining. So we're getting tight on time, or we have I think 12 minutes left, and I think we're almost at an hour and a half now. I do have an example. I'll just show you like sort of a quick. I was going to dive a little bit deeper, but rather than go too deep, I'll just kind of quickly show you this. I actually have an example of using a tool called Dust, which is basically a prompt chaining tool. It's a user interface. of a web search assistant. And Dust is just basically a visual interface to do prompt chaining. And what you're seeing in this block, you basically have inputs. Those inputs are a question like, who is the president of the United States? And then you can build up these chains that combine web search with little code snippets, with large language models to extract things. And this particular chain, which has a dozen or so steps, which I'm not going to go through, actually generates does a number of web searches. Does 3 web searches for every question. Then does a headless browser that reads the actual pages of those web search, injects that back into the context, summarizes those web search results, then tries to answer the question, and then tries to cite the reason why the question was answered, right? So that you actually know, hey, is this thing hallucinating? Can I actually go click on something, have a link, see the results? And so if I run this example, I won't go through it in depth. Feel free to email me and I'll send you a link to it. It's now running through this chain, and it's just simply running a series of steps of large language models and little like a web search result using some API. And this actually sort of took maybe a couple hours to implement, which is basically replicating these papers. And what you have out the results at the answer. So my first question is, who is the president of the United States? And here you basically get the result out. The current president of the United States is Joseph Biden Jr. So it got it correct. This is using OpenAI, so it's up. Even the OpenAI model, which was previously failing, is working. It talks about who he was previously. Prior to him was Barack Obama. It cites that, and then also for some reason decides that it's going to tell me who the first president of the United States is. And it's that. It has a site for that. If I say show all, and it talks about what's the need, what are the guidelines to becoming president? You need to be natural born. You need to be 35 years old. Not exactly my question, but more information that's nice. And the great thing about it is for each one of these statements that it's making, for every statement sentence that it's written, it's actually, and if you go through here, you'll see how I do this. It's actually generated a citation. So what I've done is I've actually built something that now is a question answering bot that actually generates a citation. And I've done this all without training any models. All I've done is I've chained together these models and empowered them with tools. I've empowered them with tools, not by training some sort of fancy thing, but by building a kind of a clever way to do generation, where it's the model would simply complete itself and say, search for this, right? Then I would go and look at those search results and summarize them and then inject them into the context and then answer the question now with a much richer context, even though my original context was simply this very basic, who is the president of the United States? I even got a typo there when I did that. So super cool, very, very powerful what that can do. Okay, pros, tool use and prompt chaining, extremely easy to extend large language models with web search, calculators, APIs, etc. Tool use is a natural path to tie into proprietary systems or data. I think, if you think about your internal APIs, it's privacy preserving. So again, because we're not training it on any customer data, it's easy for us to preserve privacy or build chains that work on proprietary data or customer specific data, but have those guarantees into the structure of that chain. And it enables complex task completion via much smaller and simpler tasks. And so I think it's going to be very powerful for many knowledge work and creative tasks. The cons are, it's, you can, as you saw from that example, it becomes a little bit more complicated than one API call. You're still stuck with the sort of limited context of 4,000 tokens. They can sometimes go off track, right? None of these things are super deterministic. So sometimes you need retries, or things don't come back in the format that you're maybe expecting to parse it. And they can get slow, right? They can, if you're having many, many steps, they can get a little slow. So depending on your user experience, that might be not great. Of course, finally, don't give them access to the launch codes, right? We don't want to sky that situation. Web search, on the other hand, is probably fine. So that's it. I think I'll conclude with 2 other very short slides. I mean, to me, I think hopefully you've got a sense for extremely exciting times. You can do a tremendous amount with these tools. They're easy to use, and they're enabling fundamentally new capabilities. I actually think we're entering a world where I haven't talked about a lot that's going on. I've really focused on text models here just because I had so much content. I haven't focused on some of the most exciting areas that are coming. And so if you just think about, just to touch on that very briefly so people have an idea, which is my own opinions of where things are going and what's next. Number one, models are becoming multimodal. And so, I mean, right now, if you're on Twitter, if you're paying attention to this, obviously you're seeing that models right now are starting to being able to generate amazing artwork. All of these images here are images that I created using either Stable Diffusion or OpenAI's DALL-E. And there's tools out there that you can play around with themselves. They're not perfect. They get 6 fingers, not 5 fingers. Faces are a little bit messed up, but the rate of improvement is dramatic. And I think we're going to see not only images, but audio, video, 3 dimensions. Over the next couple of years, there's been immense progress in making these models multimodal, and then we'll have to think about what use cases can use that. The models are going to get way better. Not everything worked in these demos, as you saw. It's exciting, but man, they do fall over still. Who knows where I would say who knows where it's going to go. I think most people that are kind of really following the pulse, there's no question that even with the current techniques that we have, without major research breakthroughs, there's going to be dramatic improvements of performance over the next year or two. And so I would say bet on models getting significantly better. Still will struggle with a lot of tasks, but they're going to get significantly better. Models are going to continuously learn, whether that's through continuous training from service providers like OpenAI, or whether that's through augmentation with search like I just demonstrated. It's clear that there are obviously ways to solve this, right? The search ones are super easy to implement. I anticipate that either there'll be easier ways for you to implement them off the shelf, or these models will be baked in. These capabilities will be baked into the underlying service providers. And then finally, I think one thing that is still really a research question and is very important once you get into the weeds is these models are going to be increasingly steerable, alignable. They're going to increasingly be better ways to follow your tasks. I think it's very unclear what this is going to be. Currently, it's a lot of focus on prompt engineering. I don't know, is it dialogue systems? Is it soft prompts? There's many, many different ways to try to figure out how can humans and these AIs work together and understand the desires or the goals of the human, decompose complicated tasks into small digestible pieces that I can understand as a human. How is that going to be done? That's not an easy problem. What are the user interfaces to get that feedback, to interact with that, to iterate on it? Knowledge work and creative work is highly iterative. And so I think that's open question. So with that, I think this final prediction is from Sam Altman, president of OpenAI. I think I agree with it. AGI, artificial general intelligence, will probably get built, or at least elements of it, like around text, are going to get built sooner than people think. Or there's going to be remarkable things that happen over the next couple of years. I think it will still be a struggle to think about how do you use this? How do you build new product experiences? How do you improve productivity, creativity, augment human potential with it? Having tried to build tools like this, it's still going to require a tremendous amount of human creativity to figure that out. And so I think that's something for everybody out here to think about. With that, we have 5 minutes left. I'll jump into the questions. I'll quickly look and try to answer one or two. Thank you, everybody. I hope a few of you stuck around and enjoyed it, learned something, got some intuition. I enjoyed sort of walking through all these examples myself, and I really appreciate it. All right, so how can we extend this to answer questions to solve service related to a project using both articles? So I think, yes, the whole support case is a question around, how do you do this in the biggest? I think it's probably around the search augmentation. I think there's lots of opportunity in the service space. I think you can build chatbots, right, that obviously are much more fluent, that really understand what the customer is asking. I think it's critical that those chatbots have access, right? OpenAI is not going to know your product, right? You're not going to be able to solve it with just OpenAI and solve your problems. But what you are going to be able to do potentially is to use OpenAI to understand the language, the text, take the text of the user, maybe background from the customer, right? A query from the customer's question to the background to a database where you've indexed all your documentation. The key thing that you need to do is you say, how do I get as much information? And currently that means into 4,000 tokens. How do I get as much information where from that, then I can say, answer the question from the customer. And then, you give it an example of a great question. But the critical thing that I think is up to you is going to be, how do you go and collect all this information from a question and then find the relevant information, which cannot be everything because it's got to be limited to 4,000 tokens. That's where some things like nearest neighbor search is super useful. Because you can get a little snippet. You can even summarize those pages. So for instance, in the example that I showed you, you didn't see this, but I read the website. The websites are too long. So I actually used GPT-3 to summarize to summarize those pages into a concise summary, and then answered the question from that summary. So lots of room for creativity is still going to be required here. Just looking through a few of these examples here, or questions. If anybody has additional questions, let me just conclude by we are working on some ideas to make all of this easier. Things like adding your own proprietary information to these models, things like monitoring them, iterating on performance at Continual. It's not currently what you're seeing on our website, but if you are interested, if you have use cases internally, and if you want to work with us to build out those use cases and to use some early tools that make a lot of this stuff much, much easier, definitely reach out to me. You can connect with me on LinkedIn. You'll see my name. You're welcome to connect with me. Email me directly. My email address is tristan@continual.ai. Just say, hey, I'm interested in what we call DaVinci internally. It's an internal tool that we're building to help with this stuff. And I'll be happy to chat with you and give you a demo of it. And just also, I'd just love to hear about your use case, brainstorm about ideas. I think we're in an incredibly exciting era. Hope you enjoyed the talk. Gave you a little bit of a whirlwind tour of what's possible. I only scratched the absolute surface really here, but as you can see, there's a lot to talk about. So with that, thank you, everybody. And I hope to hear from a couple of you offline.